Guys and girls, it's know it time!
So your first lesson today is on logs. Before I can teach you what a log really is, I have to go over some basic stuff with you, and that's called working with exponents. Working with exponents. If you can master exponents, you will master logs. But before I can teach you logs, you got to learn the basics. Before you can run, you got to learn how to walk. Okay? I'm going to give you a basic exponent. 3 to the power of x equals to 27. Very, very basic example. There's nothing hard about this, no tricks. Your task is to find x. Go for it. Find x. Very, very simple question. You shouldn't need a calculator. You should be able to do this in your head just by looking at it. Grumpy, what's your answer? 3 is correct. X equals to 3. Because a lot of you say, hey, Miss No, 3 to the power 3 equals to 27, which is correct. See, if you can do that, life gets easy for you. If you have trouble doing that, you're going to be in trouble. Now, I'm going to teach you some basic definitions. This is called your base. Okay, that little 3 right there. Your exponent right here really is called the exponent. No tricks. Okay. Exponent. So 2 vocab, 1 is a base, 1 is an exponent. Here's how it works. Let's say I give you this. 8 to the power of x plus 5 equals to 16. This question becomes a lot more challenging because some of you say, Miss Snow, how do I know what times the power of 8 goes to 16? See, this is challenging because the reason why is you're so used to working with the concept of 3 to the power 3 equals to 27. The proper way of thinking about this is how to solve. How to solve exponents. To solve exponents. The proper way to think about this is really working with your basis exponents. I'm going to give you an example. 8 to the power of 2. Okay. A lot of you know the answer is going to be 64. My base here, this is called your base, is an 8. I want you to play around with this base, change this 8. The other thing is now change base 8 into base 2. Okay. So instead of writing 8, we'll just do bleep. See, my exponent hasn't changed yet. Change base 8 into base 2. Instead of writing 8, you're going to write down 2. But you're missing one more thing. Think about what's missing. 2 to the power of 3. Because would you agree 2 to the power of 3 is the exact same thing as 8? So that's what I did. I changed base 8 into base 2. But now you can't leave like this. Guys and gals, I want you to simplify this. Back in grade 10, your teacher taught you how do you simplify 2 to the power 3 to the power 2. I'm going to let you have some fun. Go for it. Simplify this for me. But this becomes 2 to the power of... So nothing too bad. See, all I did was I made it simple. And we learned how to simplify this back in grade 10, and it was really 2 to the power of 6, because we multiply these two numbers together. Okay, that's it. So 2 to the power of 6 is the same thing as saying 64. Let's play this. I'm going to ask you to change. Let's say you have 9 to the power of x plus 1. That 9 is bad. I hate it. Change to base 3. I'm going to pause this for a second. Resume this. So now that you have a chance to try it, Monica, take a guess what your answer is going to be. No idea? Okay. Irish. Who's Irish? Irish, take a guess. Change to base 3. So here's what we're going to do. See, this 9, you can't write a 9 anywhere. There's going to be x plus 1. Okay? But now, something's missing. It has to be a 3 because I changed to base 3. 3 to the power of 2. Hey, Mr. Villar. So, guys and gals, a lot of you got up to here, but you leave it for me to do the work. You have to take this further. And I'm going to... So, now, guys and gals, you got to expand this out. So you can't leave like that. This becomes 3 to the power of 2x plus 2. That's where you should be at. Okay? It's not that hard. It takes a lot of practice. A bit more challenging for you. Good luck. I'm going to keep on making it more challenging each time. What if I give you this? 9 times 27 to the power of x plus 4. I'm going to ask you to change to base 3. The whole entire thing. Change to base 3. A bit more challenging for you. Again, this whole concept is around working with exponents. And while you're working that, I'm going to walk around. I'm going to help you out. So I'm going to pause it and for you to try on your own. Now, when I walked around, here's what I saw. So a lot of you changed piece by piece, which is correct. But you forgot to take it all the way through. Watch what happens. This 9, a lot of you said, hey, Misso, that's easy. That's 3 to the power 2. I totally agree with you. Then, times. Here's where some of you made errors. This 27. Okay? 27, let me just ask on a random student. Eeny, meeny, miny, mo. Prab. Who's Prab? Prab. What is it going to be? 3 to the power 3. And notice what I'm going to do. I use brackets every time I have exponents. X plus 4. Some of you took it a bit further and said, hey, Mr. Let's do this. 3 to the power 3x plus 12. Okay? Times 3 power 2. And then you guys circled your answer and says, hey, this is my answer. The problem with this is it's not all the way complete yet. Because back in grade 10, maybe grade 9 level, your teacher taught you what to do with exponents. When you multiply similar bases together, what do you do to the exponents? You add them. So take a minute and add these together. So you go 3 to the power of, so watch what I'm doing. I'm adding the bases. Sorry, I'm adding exponents. 3x plus 12 plus 2. See? And my final answer really is 3 to the power 3x plus 14. So this takes everything you've been learning from grade 10 all the way to grade 12. Okay? See, I add exponent, because my bases are the same. Why do you need to know this? Because I'm going to give you one more question. I'll show you why you need to work with different bases. Yep, question. Fire away.
For the exponent, it was 27 was the base, right? So even a number that doesn't have an exponent attached to it can be a base?
What was say it again?
Like the 9, it doesn't have an exponent attached to it, so it's still a base?
Yep. See, because there's actually a number. There's hidden number 1. Okay? But they don't normally use the hidden number 1. Try this one. A bit more challenging. I make it more difficult every single time. What if I give you this? Some of you hate this because you have fractions. 25 over 36 to the power of 2x plus 5. I hate that base. It's too messy. Let's change it to base 5 over 6. Wow. How would this work? Change to base 5 over 6. Go for it. You have to learn to work with fractions. You can't be afraid of fractions. I'm going to give you a few minutes to try this on your own. So guys, I gave you a few minutes to work on this, and let's see how you would do. Now, 25 and 36, this is bad. Such a nasty number. Change to the base 5 over 6 again. I want you to erase that base. My exponent stays the same. I didn't do anything to the exponent yet. I know my base has to be 5 over 6. But now, this is where the error lies. 5 to the power of what gives me 25, and 6 to the power of what gives me 36. Has to be only 2. So we'll put in 2 right here. That's all I'm going to do. You see, no tricks. Some of you did super fancy stuff and said you 5 squared and all. It's too messy. Okay? We don't want it. I want to keep it simple. And then I multiply my exponents together. 4x. Please do not say 4x plus 7. Okay, it's 10. This is wrong. Some of you will say 4x plus 7. It's 4x plus 10. So the question now is, why do we have to learn how to change bases? Here's the reason why. If you can't change the base, you can't solve the problem. It says, why do you need... Why is it 10? Because remember, we're multiplying these together. Times. So we take 2 times 2x, and then 2 times 5. Why do you need to change bases? Because a lot of you say, hey, Mr. Oak, why can't I just work with the original question? Change bases. In logs, it's all about base and exponents. You have to master the bases really well. I'm going to give you a question. 3 to the power of x, we're going back to old school, equals to 27. A lot of you know what the answer to this already just by looking at it. Say the answer is 3. Okay, x equals to 3. But the question is, why? Why is it equal to 3? Some of you say, hey, 3 times 3 times 3 is equal to 27. That works well, but here's another logical explanation. Look at this 3. Look at this 27. There's a common base between the two. Try to make the bases the same. So I want you to do is find a common base right now. Common base. Find a common base. 3 and 27. What's the lowest common base between the two? 3. So if this is a 3 already, I say the same. But hey, look at this 27. 27 is bad. Change 27 to base 3 right now. That would be 3 to the power of 3. Hey, look at this. If your bases are the same, you cross out the bases and you only work with exponents. See? My bases are the same already. So cross out this 3, cross out this 3. Because if bases are the same, your exponent has to be equal to each other. And that's why x equals to 3. Okay? I was like, that's why we changed bases. Here's the reason why. I'm going to go back to that nasty question I gave you before. The one that a lot of you had no clue how to solve. 8x plus 5 equals to 16. So let's copy this down. 8x plus 5 equals to 16. If you try to solve this on a calculator and just look at it by it, it's almost impossible to do. But if we use logic and try to work with the basis, It makes your life easier. Guys, gals, good luck. Solve this now. I'll give you a hint. Okay? We've been working with our bases. Find the common base. There's a common base between the two. That's all I'm going to give you your hint. Good luck. I'm going to pause this for a few minutes and let you try it out, and I'm going to walk around. So I walked around, and I looked at all your work, and a lot of you said, hey, look, there's a common base. The common base is a 2. So let's change everything to base 2. So this is 2 to power 3, x plus 5. And this is 2 to the power of 4. Take a look what I did. Okay, I'm going to expand out the top part. 2 to the power 3x plus 15 equals to 2 to the power 4. If your bases are the same, cancel out. If my bases are the same, my exponents have to be the same. Gone, gone. Okay, so just rewrite this as 3x plus 15 equals to 4. And guys, gals, pure algebra from there. Abraham, what's your final answer? X equals to negative 11 over 3. Hey guys, that's nothing too hard. All it is a logical step. If you follow it, it's very simple. If you try to start getting freaked out, you're going to be in trouble. Now, I'm going to go over some next stuff. I call this stuff tricky exponents. There's only a few more stuff, and then I'm going to get you practice your package. Tricky exponents. What slash basis? Your base you're going to work with is 27 to the over 64 to the power of negative x plus 10. 27 over 64, such a bad number. Let's play around with this. Change to base 4 over 3. Let's see if you can figure out the trick to solving this. Good luck. I'm going to pause it, and I'm going to let you have some fun. So I walked around, and I heard first person says, hey, Mr. No, I think you made an error. Shouldn't the base really be 3 over 4 and not 4 over 3? The answer is no. That's why I call it tricky exponents. See, your life would be a lot easier if it's 3 over 4, but back in grade 8, your teacher taught you something called how to flip your fractions around. How do you flip your fractions around? If I go 4 over 3, it is negative. When you have a negative exponent, it flips the fraction around. So your answer has to be a negative exponent. So what is the negative exponent going to be? Negative 3. Because 4 over 3 to the power of negative 3 really is the same thing as writing 3 over 4 to the power of 3. These are identical. Okay. So when you want to flip your fractions around, use negatives. Okay, so let's write this down in case you forget. If you want to flip your fractions, then use negatives. Use negative exponents.
Where did the negative 3 come from?
Where did negative 3?
Yeah.
Ah, good question. So we want this 4, would you agree, matches to 64?
Yep.
And this 3 matches to 27? 3 to the power of what gives you 27? 3. 4 to the power, and 4 to the power 3 also gives you 64. So guys and gals, this whole entire thing really becomes 4 over 3 to the power of negative 3. And be careful, there's my original exponent hasn't changed yet. Go ahead and simplify. Go ahead and simplify this right now. 4 over 3 to the power of negative 3 to the power of negative x plus 10. And go ahead and simplify this on your own. 3x minus 30. Hey, that's it. You will have to learn how to flip these around left and right using negative exponents. They will play around with tricky exponents for you. Okay. What else can I give you before I start the work? Try this one. How to get rid of exponents. How to get rid of exponents. Sometimes you may, if I give you a question like this, x squared equals to 64. Okay. In this question, my base is an x. X is no longer an exponent. So I want to get rid of exponent. A lot of you know what to do and say, hey, Mr. No, that's easy. I'm going to do the square root. X equals to the square root of 64, which gives you plus or minus 8. Easy stuff. If I want, I just do the opposite. What if I give you x cubed equals to 64? You may need a calculator for this. Guys, gals, use your calculator if you have to. X cubed to the power of 64. Plus or minus 4? For this case, it would be just positive 4 only. Only when you square root is when you have plus or minus. So here's my calculator. A lot of you will be using one of these calculators. It's mandatory. I will be collecting money for a deposit to use this calculator, and I will hand out these calculators for you guys in a second. So let's clear this out. So how do you get rid of this 3? That's the question. Cube root. So a lot of you want x 64 cube root. That works fine. But what if I give you a lot more complex one, such as x to the power of 5 over 2 equals to 17. See, this one, some of you say, what the heck is 5 over 2? This, if you want to solve for x, I'm going to show the trick right now. To get rid of exponents use the reciprocal. Okay. So we're going to take the reciprocal. So it'll be x equals to 17 to the power of, guys, here's 5 over 2. Take the reciprocal of that. 2 over 5. Punch this in your calculator right now. So we go 17. Hit your exponent button right there. I like to use brackets. 2 divided by 5, end bracket. So your answer is 3.1. So x equals to 3.1. Try this on your own. X to the power of 4 equals to 100. Solve for x. This technique works with any kind of exponents you want. The moment you take a reciprocal of it, it gets rid of it. So x equals to 100 to the power of 1 over 4. That's the same thing as saying the fourth root. So watch what we're going to do. 100 to the power of 1 divided by 4. Bada bing, bada boom. So the answer is 3.16. 3.16. One last question, and I'm going to assign you your work for today. Good luck with this one. What if I give you this? 4x to the power of negative 2/3 equals to 16. Solve this on your own. I'm going to pause it, let you have some fun, work with the person beside you. And so let's start with meeny, miny. Giselle, where's Giselle? Who's Giselle? Oh, Giselle. What did I get rid of first, Giselle? Divide by 4. Good. So now this becomes x to the power of negative 2 over 3 equals to 4. Okay, again, nothing too bad. Amanpreet. Where's Amanpreet? Amanpreet, what do you do now? How do you get rid of this negative 2 over 3? Good. So x equals to 4 to the power of what? 3 over 2 negative. The signs don't change. So the only thing you did was you did reciprocal. And punch this in your calculator and solve it and you're done. Or you just leave it like that. This ends your lesson for the first part of logs. If you're good with bases and exponents, you will be fine. Okay. Your homework. Take out your log package, please. Page 30. I don't want to give you too much work. So just number 1, 2, 3, and 5. Just 4 questions.
So our quiz is going to be from the homework?
Yep, straight from the homework.
Those are going to be those questions?
Those questions. 1, 2, 3, 5. Guys, this ends your lesson for today.